Hello everyone, Mr. Minix, my name, math is my game. I'm joined here with my second period Algebra 2. We're looking at, they're really excited about Monday, I'm glad. So, this is going to be function operations, and composite functions. This is a two-part set of notes. And actually, in this part, what we're looking at is the second part of this, the composite functions, okay? So if you've already seen part one, you should have a good idea what domain is, how to add, subtract, multiply, and perhaps even divide functions and find their domains. So in this section, what we're going to be doing is looking at composite functions. And I'd like to start off with a real simple example. If you know the answer, please don't shout it out, but just kind of hold it till the end, and we'll come back and apply what we pick up in this to this first example. So example one, a store is having a sale on a $75 item. Could be whatever. I'm not sure exactly what costs $75. Maybe a pair of shoes, maybe a nice purse, maybe a dress. I don't know. So anyway, a store is having a sale on a $75 item. You have a $20 rebate. The item is on sale for, we'll say, 20% off. Another store has the same item on sale for $20 off, and you have a 20% off coupon. Maybe we should change that first store to store, maybe we'll call it Store A. Store A. Store A. We could give it a name. Kmart? Kmart. We'll just make it real. Kmart is having a sale on a $75 item. You have a $20 rebate. The item is on sale for 20% off. The other store, what's the other store going to be? Walmart? Okay. Walmart has the same item on sale for $20 off, and you have a 20% off coupon. So the question is, and we're not going to answer it right now. We're going to come back and apply what we learned to answer this. Which store has the best deal? And we'll answer a couple follow-up questions to that also. Question. For the Kmart, the rebate comes after you buy the thing, yeah. The rebate comes after you buy the thing. And to simplify the calculations, we're going to disregard sales tax, okay? So we're going to come back and answer that. You probably already have the answer to this or are well on the way. So there's another one that I want to look at, and it goes like this. Example 2, you have a 20% off coupon for a $100 item that is already marked 30% off. How much will it cost? Now, I have seen enough practice tests on the OGT to know that this is an OGT test question. I've seen enough ACT tests to see that this is an ACT test question and everybody misses it. Well, not everybody, but about 85% of people will miss it. And again, we're not going to answer this one just yet. We'll come back to this one. But you have a 20% off coupon for a $100 item that's already marked 30% off. How much will it cost? These are practical applications of what we're going to be studying today. So if you're wondering, when am I ever going to use this? Well, this is one of those practical applications. This is probably the most practical math idea in the world. Okay? So first we need to think about what a function is. A function is a machine. I was looking up images on Google earlier about functions. A function's a machine. Let's think about what a machine does. Anybody ever watch old cartoons when the little kids take the boxes and they do some kind of magic spell on the boxes and they put their little teddy bear in the box and the teddy bear comes out and it's alive and it's huge and it rules the world or something like that? You know what I'm talking about? So that's really what a function does. So let's consider f of x equals a real simple one, x squared. Okay. If we plug x into it, or a particular value of x, like 1, f of 1, that means let's plug the number 1 into the function and see what happens. So that's going to be 1 squared, which ends up equaling 1. So that wasn't very exciting. But if we plug something like 2 into it, we would get 2 squared, or 4. And if we plug something like 3 into it, we would get 3 squared, which is 9. So with a function, we've got these things right here, this 1, this 2, and this 3. And then we've got these things here, this 1, this 4, and this 9. The 1, the 2, and the 3, anybody remember the name we called those? It starts with an I. A what? Not an index. Think back to when you first started talking about functions in like 7th grade, or with domain, when you learned the definition of domain. An I word. Think about computers, not integer. How about input? Right? What it is that we're putting in. So the 1, the 2, and the 3, those are the inputs. And then the 1 and the 4 and the 9, we could think of those as outputs. Okay? Output. Okay? So a function really is a machine. So let's think about another function now. Maybe, and let me see if I can slide all this over, if I got room to do that. Shrink consider down a little bit. Okay, so let's look at g of x now. G of x, we'll say g of x is x minus 3. Okay. G of x is x minus 3. So let's look at what g of 1 would end up equaling. G of 1 would be let me get my shade here. G of 1 would be, somebody said negative 2, because, yeah, it's 1 minus 3, so it's negative 2. Good. And G of, I guess I want to use the same colors here. G of 2 would be 2 minus 3, or negative 1, right? And G of 3 would be 3 minus 3, or 0. Okay. How's everybody doing so far, all right? Pretty easy so far, huh? We put something into a function, we get something out. We put something into a function, we get something out. There's our inputs again. And here are our outputs. Okay. Well, what we're going to do is we're going to be putting two functions together. And it's called a composition. Okay. So a composite function is the amalgamation of two or more functions. I hope I used that word right in the right context. You're probably thinking, what does amalgamation mean? So maybe we better look that up. I'll give you a minute to write that down and then we'll look it up. A composite function is the amalgamation of two or more functions. I felt like using one of my master's degree words today. Amalgamation. So let's go to Merriam-Webster and see what amalgamation means. Amalgamation. Amalgamation. The action or process of amalgamating. Thanks, Webster. You really helped me figure that out. The state of being amalgamated. Thanks, Webster. The result of amalgamating. Let's look up amalgamate. Where did cozen come from? I don't care what it is, if it's the word of the day or not. Amalgamate. Maybe I shouldn't use fancy words. Here we go. Amalgamate. To unite in or as if an amalgam. Boy, they just keep using a circular argument, don't they? To blend, to combine, to commingle, to commix, to composite. Look at that, to composite. Or a synonym is composite. So there you go. Intermingle, interfuse, integrate. It's not integrate in this context. To meld, to merge, to blend, to mix. The opposite of breaking up, the opposite of separating, the opposite of unmixing, the opposite of breaking down. So let's see. Notationally speaking, we use this weird notation. Okay? Notation. F weird dot G left parenthesis X right parenthesis is read as the function f of x composed with the function g of x. So that weird dot, some people call this notation the fog notation. Okay, so what I'm saying is this weird dot right here, this means composed with. Composed with. Okay. Different textbooks, Math Excel, the printed homework, different things will use different notation. Okay. A notation that I prefer is this notation. F left parenthesis G left parenthesis X is read as f of G of X. And it means the same thing as F composed with G. F of G of X. And it means the same thing as F composed with G of X. What do we think so far? A piece of cake? Well, I don't know. It's looking a little scary. So you're probably wondering about this process, about how it works, about how we go about doing this. And honestly, PEMDAS answers almost every question in math that we might have about some things. And PEMDAS answers this. Composition of functions is essentially substitution from the inside out. That's all it is. It's substitution from the inside out. In order to take two functions and compose them, all you're going to do is substitute from the inside out. What do we think? Not sure just yet? Well, I hope I got my pictures of SpongeBob because I'm going to use them. Before we go any further, I'd like to give a shout out to the future Mr. Minnick. I hope you're feeling better. I'd like to give a shout out to Will Duvall. He gets a shout out in every video. I don't know why him, but another shout out to the future Mr. Minnick. Okay. Who else? The YouTubers that are actually watching this. Okay. John Lennon. All right. A shout out to Dane Burrows. Okay. Okay. He's asleep right now and should be awake, but he might watch it back. Okay. So we're going to find both f of x, both f of g of x and g of f of x. Okay. The reason we're going to find both of these is because I want you to realize compositions of functions, sometimes you end up with the same thing, the same result, and sometimes you don't. It's kind of rare that you do end up with the same result. So let's go. F of g of x equals, remember what we said on the last page of the notes here. Essentially, this is just substitution from the inside out, right? Substitution from the inside out. Well, what are you talking about? What I'm talking about is this. G of x is defined as x squared. Is everybody with me on that? That's given in the problem. It's given. Composite functions is substitution from the inside out. So in other words, what I'm going to do is I'm going to replace g of x with its definition, with how it's defined. And what's g of x defined as? X squared. So I'm replacing that component with x squared. Everybody okay so far? Now, here's where I get into a little bit of trouble. So when you go home today at the dinner table, and if your folks ask you, what'd you learn about in school today? It could be kind of an interesting conversation. Because now, you know what we're going to do with x squared? We need to F it. We need to F it. What I mean by that is F left parenthesis of something means, you know, whatever it is in those parentheses, whatever it is in that group, we need to put that in the function. We need to put that in the function f of x. Okay. So what's going on is we still need to F this. Okay. I know it sounds funny, but do you see what I'm saying? We need to put it into the function f. Now, when we put it into the function f, it's going to take the place of x. A lot of people drop the ball on this. But what's happening now is this. Now I'm going to take this x squared, and I'm going to replace it in the function f in place of x. Does that make a little bit of sense? Because I'm not effing x this time, I'm effing x squared. So x squared takes the place of the variable x. So what I do then is I'm going to get x squared plus 1, and that's the answer for that. That's it. That's it. Was that bad? No. So let's try the other way then. Let's try finding g of f of x. Okay. Again, we substitute from the inside out. In other words, we're going to substitute and we're going to replace f of x with how it's defined. And how's f of x defined? X plus 1. So we're going to take x plus 1 So there's x plus 1. And now we've got to remember that we still need to g it, because we do still have to g something, and we're going to g x plus 1. Okay, we got to be careful when we do this. The function g says take whatever your variable is and do what to it? Square it. So in this step, what we're going to be doing is we're going to be squaring that variable. And I'm going to skip a couple steps, and some of you are going to say, but I hope you get where this comes from. So the answer on this one, the answer on this is going to be x squared plus 2x plus 1. And if you don't know where that came from, think we have to expand that. We have to FOIL x plus 1 times x plus 1, and we get plus x, and that's where the plus 2x in the middle comes from. Okay? What do we think? Got the idea? Now, that looks a little intimidating at first, and there is good news. You want to know the good news? The calculator can do this with numbers for you. Let's build on this. Let's go to example 3. Let's find, for, what was f of x? For f of x equals x plus 1, for f of x equals x plus 1, and g of x equal x squared, find each of the following. Let's find f of g of 7. Let's find g of f of 7. Let's find f of g of 2. Let's find g of f of negative 3. Now, wouldn't it be nice if we knew what f of g of x was? And we do from the last problem, right? So we could kind of steal that. I hear there's a shout out to Mr. Englehart, because he knew that this was 50 right away. Let's see what f of g of x is. I'm just going to write f of g of x. That was x squared plus 1. And g of f of x was x squared plus 2x plus 1. Okay, I kind of stole those from the last problem. So let me shrink those down for a minute. And my writing is really bad today. I apologize for that. So Mr. Englehart said 51, so he's right. If we were to evaluate that with that function, it would go like this. It would be 7 squared plus 1, or 49 plus 1, or 50. Now suppose we didn't know what f of g of x was. Suppose we didn't know what f of g of x was. In that case, when we start with g of 7, we would go to the function g. So we would say, okay, so it's 7 squared. But then we have to take that, and we have to f that. Does that make sense? Because that f is still before it, okay? So we simplify it, and we're going to take f of 49. And that means let's take 49, let's plug it into the function f in place of x. So then that means it's 49 plus 1, which is 50. Okay? Can we see how to do that? So you could do that with the part from before, or you could do that without the part from before. It honestly doesn't matter. Okay? What about g of f of 7? What's that going to equal? G of f of 7, let's take f of 7. That's going to be 7 plus 1. And what do we need to do with 7 plus 1? Well, we need to g it, right? We do need to square it, but we need to g it. Okay? So we're going to take g of 8, and what's that going to be then? 64. Okay? So let's look at the next one, f of g of 2. F of g of 2. So we're going to take 2 and g it. So it's going to be 2 squared, and then what do we have to do with 2 squared? We have to f it, which means plug it into the function f. So it's going to be f of 4, and what's f of 4? 4 plus 1, which is 5. I find that some people think it's easier to do this with numbers than it is with variables. F of g, or g of f of negative 3, let's see. So this is going to be negative 3, I'm sorry, it's g of f of negative 3. So it's negative 3 plus 1, and we need to g that. So that's going to be g of what? Negative 2, so we take negative 2 and we square it, and what do we get there? We get 4. Would we like to see how to do this on the TI Inspire? Check this out, it's so cool. So cool. On the TI Inspire, what we're going to do is we're going to define the function f of x. We're just typing it, define f of x as x plus 1. We're also going to define g of x as x squared. And so then we could find f of g of, what is it? F of g of 7. F of g of 7, there you go, it's 50. G of f of 7. G of, whoop. Let's try that again. G of f of 7. Bam. Do we get the idea? Questions, comments, concerns? Okay, let's try example 4. F of x equals the square root of x plus 1. G of x equals x cubed minus 5. Find f of g of SpongeBob. So if you want to make this x to make it easier, you probably want to make it x in your notes. Okay. So f of g of SpongeBob. So f of g of SpongeBob. Remember what we do with this is we substitute from the inside out, right? So the first thing we're going to do is take g of SpongeBob. So that means let's take SpongeBob and do what with them? Not square them, cube them. So we're going to cube SpongeBob, and then what? Subtract 5. So that right there, let me get my highlighter going. So when we're asked to find g of SpongeBob is that right there, right? Now what do we have to do with that? We have to f it. In other words, we have to put that into the function f in place of the variable x. That's all taking the place of the variable x. So the function f says we've got a square root of something. We're going to be adding 1 to whatever the variable is. And what's the variable? The variable is not SpongeBob. The variable is SpongeBob cubed minus 5. We could simplify that a little bit into the square root of SpongeBob cubed what? Minus 4. Okay? And that's what we do. That's it. What do we think? It's not that bad. Not that bad. So let's back this thing up and let's pick up our example 2. Example 2 says you have a 20% off coupon for a $100 item that's already marked 30% off. How much will it cost? Everybody says $50 and they're wrong. It's not $50. There's several different ways to do this, but what I'd like to do is this. I'm going to say let f of x equal 0.8x. What this is this is that 20% off coupon. Okay? If it's 20% off, you're paying the complement amount. You're paying 80%. Okay, so f of x is a function that represents that 20% off coupon you have. Is everybody with me there? What I'm also going to do then is I'm going to let g of x equal 0.7x, and this represents that 30% off. Okay, everybody with me there? Now at this store, you have this coupon, but it says the item's already marked 30% off. It's already marked 30% off. Let me get my highlighter going here. Since this is already, since it's already 30% off, what are we going to apply first? The 30%, right? So are we going to take f of g of x or g of f of x? It's going to be f of g of x. Okay, so what we're really finding here is f of g of x. Okay, if we do this for the general case, we'll see how much this is for any priced item. But do we want f of g of x, or in this case, do we want f of g of 100? So you want to go ahead and plug the 100 in and see what happens? Okay. So let's make it f of g of 100. So g of 100 means we're going to replace, and remember, substitute from the inside out, g of 100. We go to g of x and place 100 in there. So that's going to be what? 0.7 times 100. And we still have to take that and f it, right? So what is 0.7 times 100? 70? So we have to take 70, and we're finding f of 70 now. So what's that mean to find f of 70? It means plug that into the function f in place of x. So it's going to be 0.8 times 70, or $56. $56. Drops the mic. Drops the mic. It's not 50, and everybody and their mother says 50 on one like this, and they always miss it. Okay? Any questions about that example? Okay, let's back that thing up to this one. Kmart is having a sale, $75 on a $75 item. You have a $20 rebate. The item's on sale for 20% off. Now the rebate usually comes at the end of the sale, right? So let's see what's going on here. Let's say that f of x, equals the x minus 20. Okay, so that's the rebate. And g of x equals 20% off, so 0.8x, right? So what's Kmart got going on? Is Kmart going to be f of g of x or g of f of x? Kmart is going to be f of g of x because you get the discount later. You get the rebate at the end. Okay, so Kmart is f of g of x. So Kmart would be f of g of x. And Walmart would be g of f of x, right? G of f of x. So f of g of x is going to be f of, I need the whole page on this. F of what? F of 0.8x, which is going to be 0.8x minus 20. And Walmart's going to be g of x minus 20, which is 0.8x. It's 0.8. Oh, it's 0.8 times x minus 20, like that, right? I got that going on the right way there. So this is 0.8 x minus 20. So let's see. Well, that's not going to work. Let's plug in our $75 item and see what happens. My smart board's not cooperating now. It doesn't want to erase. That's okay. I don't know why it's not erasing, but that's okay. All right, so now it doesn't want to write. 0.8 times 75 minus 20. So what's that? .8 times 75 minus 20 is going to be 40. So Kmart's going to be 40 bucks. Walmart's going to be 0.8 times 75 minus 20. So that's 0.8 times 45. Is it 55? You're probably right. You're right. It's 0.8 times 55. 0.8 times 55, which is 44. Who's got the better deal? Comes down to a debate about price match or not. But the deal is, I hope that you realize that with this, you can see that it doesn't matter when you take that discount, when you use the coupon. Okay, it really does matter. So do your homework, literally and figuratively speaking. The Math Excel homework on this, the composite functions. We haven't talked about domain and range yet. We'll have to pick that up at some other time. So anyway, it's been real. It's been fun. Anybody have any shout outs? Seth Morgan? Anybody else? James Pietzu? Okay. Anybody else? Lauren Jones? Okay. All right. See you next time.
Good.